Hi guys, today we're looking at multiplication or product. So we're going to look at multiplying a monomial by binomial, and at some point we'll be looking at multiplying binomial and a trinomial. Let's look at this example first. So in our first example we have 2x into x squared plus 3. So let's look at this problem here. So we're saying that we want to multiply it out. So let's label this one as a coefficient. So this is our coefficient. And then let's look at x as our base here. So our x is a base. Then let's look at this 2 here. This 2 here. So that 2 there is known as an exponent, or we call it an exponent. Alright, so let's say we want to multiply this out. Let's write it properly here. So we have 2x into x squared plus 3. So what is happening here, if you want to multiply out, you have to multiply all this term here with whatever is inside here. So you multiply that you also multiply it with that one, which is 3 in this case. So this will be equal to, so we're looking at 2x multiplied by x squared. We keep our positive, and then we have 2x multiplied by 3. So let's look at it. So because here we only have one coefficient, of which is 2, so we keep our 2. So and then we multiply x times x squared. So x, when the bases are the same, you add the exponent. So this will result to x to the power 1 plus 2, because the bases are the same, of which is x. So we need just to add the exponent plus. In this case, we have a coefficient of 2, and then we have coefficient of which is 3. So we only have x as a base. So we have to say 2 times 3, and that gives us 6, and x remains. So the answer will be 2x cubed plus 6x. Hence we have multiplied, or we have expanded. Okay, so let's try to look at this example here, of which we can call this as an example 2. Okay, let's look at our example 2. Our example 2 is a binomial by binomial, and it's written as 4x plus 4 into 3x plus 2. So because this is a binomial by binomial, we have to multiply the first term in the first bracket with this term, with the first term. So it's x times 3x. We do the same thing here. We also multiply x with 2. So we do the same thing. We have to multiply 4 with that one, and we also multiply 4 by 2. So what will happen here, if you're saying x times 3x, this is the same as 3x squared. Remember, when the bases are the same, when you're multiplying, you keep the base and then you just add the exponent. And then this here, if you're saying x times 3x, is give you 3x squared, and if you're saying x times 2, you should get 2x. And if you're looking at 4 times 3x, then you must get 12x. If you're looking at 4 times 2, obviously that would be 8. So we're looking at adding terms that are like the like terms. So here we'll keep our 3x squared. There is nothing else that has a squared beside 3x squared. And then if you look at the next term, you're finding 2x. So you need to add 2x plus 12x because they all have the same basis. So you just add them. So in this case you'll have 14x plus 8. Okay, because the bases are the same, you just add the coefficient of which is 12 and 2 in this case. So you are done. Let's look at the next example. We can call this example 3. So this is our example 3. In this case we're looking at 3x minus 2 into 5x plus 8. Okay, so this is also a binomial by binomial. So we have equal to. So if we're looking at multiplying this, we have 3x times, we have 3x multiplied by 5x, and then we have plus 3x multiplied by 8, and then we have minus 2 times 5x, and we also have minus 2 times 8. Can you see what is happening? We multiply that with that, and we also multiply this with that. We do the same thing. We multiply this with that, and we multiply this with that. So you see, we're always using negative 2 times minus 5x, negative 2 times 8. So our answer should look like, so we have 3x times 5x. So we multiply first the coefficient, then we should be getting 15. Okay, so we're getting 15. So we have our 15x. So because it's x times x, 3x times 5x, so it will be 15x squared. And then we carry on, we have plus 3x times 8. Then 3 times 8 should be 24x. Then we're looking at minus 2 times 5x. That should give us minus 10x. And we're looking at minus 2 times 8. That should give us minus 16. Then we need to look at the like terms. So we only have one term that has squared, so it will be 15x squared. You can see also the like, we have a common base here of which is x, so we're looking at the like term. So we'll have 24. So because this is x and this is x, it's the same, so we have to add the coefficient of this, of which is 24 and 10 in this case. So you have 24 minus 10, and that gives us plus 12x minus 16. So we're done with our example. Let's look at the example that can be maybe a little bit different or somehow challenging. Let's first look at it. Because of space, we'll have to use the same space, and we have to write it here. Okay. We have to write it here. So this is our last example. We can call it example 4. Let's look at example 4. So in this case we have 2a into a minus 1, and we have minus 3 into a squared minus 1. So we need to multiply this. This is the same as 2a times a minus 2a, because the reason we're saying minus 2a, we first multiply 2a with a, and now we're multiplying 2a with minus 1. That's why we're getting minus 2a. And then we move to the next term where we're getting minus 3a squared. Because here we're multiplying a negative with a negative, so we're getting positive 3. Because we're multiplying minus 3 multiplied by minus 1. Then we move to our next step. So now we're multiplying 2a times a. That should give us 2a squared. And then minus 2a minus 3a plus 3. So what should happen here? So this is 3a squared, sorry. So you see we have two terms that have squared, this term and this term. That means we need to add it, we need to put it together or closest to each other. So we have 2a squared minus 3a squared minus 2a plus 3. And then you can see we have 2 minus 3. That gives us minus a squared. You see, minus a squared is the same as minus 1a squared. It's the same thing. And then we can proceed minus 2a plus 3. So for today, that was it. If we're looking at multiplication or we're looking at the product, so that is how you approach